Hello everybody. In this lecture we are going to discuss the continuity of a function. Types of discontinuity, we have different types of discontinuity. Number one, the removable discontinuity. If a function f of x, its limit when x approaches c equals L, but f of c is not defined or f of c doesn't equal L, so in this case this discontinuity is called removable discontinuity. So we can remove this discontinuity by redefining the function to be fc equals L. Type number two, if the limit of f of x when x approaches c from the positive side doesn't equal f of x when x approaches c from the negative side, so the right limit and left limit are not equal, so it is called jump discontinuity. On the other hand, if the graph approaches a vertical asymptote at c, so it is called infinite discontinuity. And now we have to discuss the continuity of a function at some point. We have three conditions to prove that a function is continuous at some point. A function f of x is said to be continuous at x equals a if each of the following conditions is satisfied. F of c is defined, and f of x when x approaches c from the positive side equals the limit f of x when x approaches c from the negative side. So the right and left limit are equal. And f of c equals limit f of x when x approaches c. So here we have f of x, its limit when x approaches c from the positive side equals limit f of x when x approaches c from the negative side equals f of c, so it is called continuous. For example, here we have a piecewise function, f of x here, and we have to discuss the continuity at x equals 0. You can notice that f of 0 is defined here. F of 0 equals 2. Limit f of x when x approaches c from the positive side. From the positive side, so we have to use this rule, sine x over x. Because here f of x equals sine x over x when x is bigger than 0. Is bigger than 0, so this is the right limit, or the limit f of x when x approaches 0 from the positive side. Equals the limit sine x over x when x approaches 0. So from the previous rules, we know that limit sine x over x equals 1. So this is the right limit. Condition number 2, limit f of x when x approaches 0 from the negative side. From the negative side, so we have to use this rule, x squared plus 1, because f of x equals x squared plus 1 when x is smaller than 0. So limit f of x when x approaches 0 minus equals limit x squared plus 1, and by using direct substitution, the final answer is 1. So the right limit and left limit are equal. But f of 0 equals 2. So f of 0 doesn't equal limit f of x when x approaches 0, so this function is discontinuous at x equals 0. We can remove the discontinuity by redefining f of 0 here to be 1 instead of 2. So if this number is 1, so f of x equals 1 when x equals 0. In this case, limit f of x when x approaches 0 equals f of 1, so it will be continuous. Another example, if f of x is a piecewise function here, discuss the continuity at x equals 0. You can see that f of 0 is defined, f of 0, x equals 0. When x equals 0, you have to use f of x equals x squared plus 1. So f of 0 equals 0 squared plus 1 equals 1. It is defined. F of 0 is defined. The right limit f of x when x approaches to 0 from the positive side 0 from the positive side. So you have to use this rule, because here you must use this rule in case x bigger than or equals 0, bigger than or equals 0, and we want to determine the limit f of x when x approaches c from the positive side. So you have to use this rule when x bigger than or equals 0. So limit x squared plus 1 when x approaches 0, substitute x equals 0, and the final answer is 1. And now limit f of x when x approaches 0 minus, so you have to use this rule, because f of x equals 3x plus 2 when x is smaller than 0. So here we have limit 3x plus 2 when x approaches 0. By the direct substitution, this limit equals 2. So this function is discontinuous because limit f of x when x approaches 0 does not exist, because the right limit and left limit are not equal. Another example. Here we have to discuss the continuity of this function at x equals 0. F of 0 is defined because here when x is smaller than or equal 0, you must use this rule. So f of 0, we must use x squared, substitute x equals 0. So f of 0 equals 0. So f of 0 is defined. And limit f of x when x approaches 0 from the positive side. So we have to use here this rule when x is bigger than 0, because we need from the positive side. So you have to use this guy 1 over x. Limit 1 over x when x approaches 0. From the previous rules in the previous lecture, the answer is infinity. So the limit does not exist. So this function is discontinuous at x equals 0. Another example, find the values of a and b such that f of x is continuous, at -1 and 2. This function is already continuous, but we have to find the values of a and b, the two unknowns a and b. Since this function is continuous, so it satisfies all the conditions of discontinuity. So the right limit and the left limit are equal. It means limit the function 4x at x when x approaches -1 from the negative side here, equals limit 4x. So if you substitute x equals -1, the final answer is -4. Limit the function when x approaches -1 from the positive side. Here x is bigger than -1, so you have to use this rule. So limit ax plus b when x approaches 1, you can substitute x equals 1, and the final answer equals -1. So we have -a plus b. Since this function is continuous at -1, so the limit from the right and from the left are equal. And now we are finding the limit at -1 from the right and from the left. They are equal because this function is continuous. So by equating these two limits, -4 equals -a plus b. And since this function is already continuous at 2, so the right limit and left limit when x approaches 2 are equal. When limit -5x, when x approaches 2 from the positive side, because we have here x is bigger than 2. And limit ax plus b when x approaches 2 from the negative side. You can see here 2 from the negative side here. So limit ax plus b equals, instead of x you have to substitute x equals 2. So limit 2a plus b. Since this function is continuous at 2, so the right limit and the left limit are equal. So we can write -10 equals 2a plus b. Now solve these two equations to find the unknowns a and b. So a is negative 2 and b equals negative 6.